Our next presenter is actually our question asker, Paraskevi Massara. So is a PhD candidate here at the University of Toronto, and Paraskevi is going to talk about MOS for research, which is a maturity model to evaluate reproducibility in research projects. Thank you very much for joining us, Paraskevi.
Thank you for having me. Just give me a second to share my slides. Yeah. Can you see my screen?
Yeah, that's perfect. Yeah.
Great. So again, thank you very much for having me. My name is Paraskevi Massara. I'm PhD candidate and I'm computational nutritional scientist. My main research interest is on epidemiology, global health, and integration of omics data, specifically microbiome. And I don't have an experience like teaching undergraduate students data science. My experience comes mostly from teaching peers and also from the collaborations of my projects. So this model actually is for study and analysis reproducibility, and it was developed and tested in the context of a design thinking course for scientists from the University of Toronto. And based on this model, we then was adapted in my work. So my screen will stop. Sorry, for a reason my slides don't move. And I'm not sure. Yeah. So I'm coming from the domain again of nutritional health sciences, and in the past, generally in health sciences, the way that we tended to approach health problems, I will take obesity as an example because it comes from my field, was from the simplifying and reductionist approach. For example, there was a clear outcome, body weight gain or obesity, and a clear cause, energy intake imbalance. And our main goal was to investigate the relationship between the outcome and the exposure. Then more complicated models were proposed to study obesity in this case, that on top of the individual factors also contained other factors like environmental setups, also demographics, and they were more complicated. However, later it was realized that even the more complicated models like the ecological models that were proposed were not enough to capture the complexity of these problems like health problems as obesity. So new models were proposed that were dynamic. And this is an example that comes from the UK, the United Kingdom, and it was published in 2007. And this illustrates the conceptual framework and the different factors that work together in a dynamic manner and affect obesity. And it's very complicated, but I managed to to group some of these interactions. They come from food production, psychology, biology, molecular biology, including activity, environment, and so on. So we tend to approach these health science problems in a more multi-leveled way, with many disciplines included, and having multiple dynamics. So exactly as we changed our perception about the problem, we may also need to adapt our research processes to this new reality. So the problems became more complex with higher dimensions, but the processes that we are still using remain the same in extent, and maybe they are outdated at some point. So Data is the token that we communicate with our collaborators and ourselves in these multi-dimensional problems. And as a result, they have been increasingly available and easy to produce. However, not always data are properly documented, which leading us to repeat some processes, analysis per se, or data cleaning. And this can create, of course, a lot of waste with regards to time, effort, and eventually resources and money. And the result is much lower reproducibility of research and low productivity for researchers. So this model was developed with the main objective to increase productivity and reproducibility in research. And this model was created for non-computer science experts from our field, including potential experts from basic science labs, for example, that do not use R, Python, or GitHub to document their projects. So many of them, the needs they have for data analysis stop to Excel. So our target audience are these researchers, these people. And this model was designed for them with the objectives to increase the awareness of data, the need of data reproducibility in non-computer science researchers, increase productivity and efficiency for data management and analysis, improve access to tools and processes for study management and reproduction, and of course, continuous improvement of internal processes. So this model has three parts. The first part is a self-assessment questionnaire. Second part, personalized evaluation based on part 1. And part 3, personalized recommendations for continuous improvement based on the previous 2 parts. I will give you some more details now on this model. And the first part, again, is a self-assessment questionnaire that covers things like how well research activities are documented, if the process is easy to repeat by team members and others, if changes in the process are documented, if the process is testable and verifiable, if there is a formal process to document the detection and the resolution of problems for future consideration, if research activities are generally planned, if project history is documented and can be retrieved, if authorship or ownership, another important point, of activities or communication between collaborators are recorded and maintained. And in the end, after having these questions, they are scored between 5 and 1. 5 is the maximum score, and whether based on whether group, project, or process satisfies completely the question or not at all. And at the end, the average score for all 10 questions constitutes the maturity level for the specific research process, group, or project. So about the outcome, the scores now, a low maturity level of 1 implies that the group does not follow a systematic or organized research approach. Number 2, the group starts to implement some organization and process in their projects, but it's still on an ad hoc basis specific to every project. Level 3, the group has put forward a more systematic approach that can be largely followed in all research projects within the same group. Level 4, the group has also begun to gather metrics about the processes itself, like productivity rate, reproducibility rate, and so on. And these metrics eventually are used in retrospect to assess how a project conforms to the applied process. Finally, maturity level 5, the group has a well-established research process that can be applied on any current project, and it's easy to adapt for future projects as well. Furthermore, the group is using quality metrics to continuously improve their process. Just to mention here that this maturity model was developed based on CMMI and was adapted for the field, the audience that we are actually targeting. This is how actually the questions look like. And after having assessed the maturity level and having a score, the part 2 of the model includes personalized evaluation, which pretty much provides recommendations to improve individual components that were not scored high enough. And particularly, they were scored with with 3 or below. So an example here, if documentation was scored, for example, 3 out of 5, we recommend that every step of the project should actually have a set of instructions recorded and associated with it. A second example, if the repeatability of the project was scored with 2 out of 5, the recommendation was to ensure that all instructions can be used by others or for different data. And if we have a score of 4 or 5, it's everything perfect, it's everything okay. So we don't provide any specific recommendations. So part 3, which is the final part, the model provides recommendations for quantifiable quality indexes so that the group can always assess and monitor their maturity and their progress. So in our guide, we provide generic minimum thresholds to achieve the desired quality or maturity level, but the group can decide and set their own goals based on these indexes and monitor their progress accordingly. And this part actually has some flexibility. So again, here we provide some examples based on the items we discussed previously. For example, we recommend at least 1 short sentence or paragraph for each step of project to create some form of recommendation and provide some explanation and description. To evaluate the repeatability of the process, we recommend that the group conducts a short usability study where they ask a colleague, the best would be not a colleague non-related to the study, to execute the analysis and measure how much time it took them to complete the task. This is something that we're actually doing now, and it's very effective. It's a very good step for a very good recommendation based on our experience. And of course, by keeping record of the time and the difficulties that the other collaborator had by repeating running the script or repeating the analysis, the time per se can be used as an evaluation metric about the repeatability of the process. And finally, we recommend that the group keeps a log about the change of the project or the process and record at least 1 comment per change. Now, for scientists, researchers who use GitHub, this might not be that difficult because the tool is available and with various commits, this can be easily tracked. However, GitHub is not that many researchers are not familiar with the GitHub, and especially from the health sciences. So they might use other tools to keep track and keep some comments on their work. So to actually test this model, we conducted a prototype study for our model and our guides, both for them, and to see how it can help researchers. It was a very small study, like research in the framework of the course. So I asked 10 graduate students who were actually involved at research projects at the time to answer the self-assessment questionnaire, and these students were actually coming from wet labs. And the model determined the maturity level of their projects and gave them personalized feedback based on their recommendations and the quantitative guide we developed. And to give you some results and some impressions, some comments from this prototype, the average maturity index was 3.6, which was actually not bad at all. It was encouraging. There is always some room for improvement. The other, of course, it was a very small prototype study, and the students we were not blinded, and they reported them, and they completed the model for themselves. It would be most likely better to have a collaborator to actually run the analysis and repeat and fill out the report, the model. The other interesting conclusion here is that the students mentioned that from their work, from their groups, they have their own pipelines. They have their own work, their rules and their routine on working, which come from past experience of the group, of the lab. And somehow this wisdom, let's say, this experience needs to be included in the model because it works for them. It might not be easily reproducible from someone else outside the lab, or might not be easy to document as a process, but they work in a way, and future models may need to take this into consideration and integrate the experience of each group. The participants of this small prototype were generally happy with the model, and they were very they showed their interest in using something else that they were not that familiar with. And they also commented on that the guide may have to be customized to cover specific domains or their studies. So in the future, it would be very interesting, actually, for those who are interested in exploring that further, to target a bigger audience. An example here is the whole Faculty of Medicine that has around 2,500 graduate students that mostly come from biology or health sciences, and they do not always have a background in computer science. And based on the small prototype we have, they may, and other experiences we have as group teaching and organizing workshops, they seem interested in exploring new opportunities in data reproducibility. And we choose this group might be interesting in particular because on the one hand, the research is very data oriented. In the end of the day, we are working in systems, and to answer health related questions, we need to work all together for many different disciplines and have biology, have psychology, have computer science, we have data science, and work all together. And what I mentioned previously, it's something new to many people, and they might be interested in exploring it. And some conclusions: reductionist research approaches. It seems that they are becoming less relevant for complex multidisciplinary projects that we need to work all together. And by not applying approaches that promote data reproducibility, we may end up to unnecessary repetitions, data waste, and eventually lower productivity. Reproducibility is a key property of research as it strongly related to the project's quality and its value to the community from the implementation science perspective. And communication through data is another key aspect of multidisciplinary research projects. And we propose, like, we tested this model, and we propose like models like the one that we developed, as they might show some potential in allowing research group to assess their practices and guide them towards increasing their reproducibility and organization in general. So again, thank you for having me. I would also like to thank my supervisors and the people, the students that participated in this course, and they participated in this model. And I'm very happy to take any questions.
This is just fascinating. Absolutely fascinating. Thank you so much for the presentation. Do folks have any questions or comments for Paraskevi? Just maybe while people are thinking, I'm kind of interested to like implement it at an undergraduate level, and like seeing the journey of our undergraduates. You think in a statistics department as they they enter first year, and presumably they're going to be fairly low, and hopefully our aim, if we're doing our job right, is that by the end they're getting fairly high. Do you have thoughts about how this could be adapted for the undergraduates, perhaps?
Are you asking me? Sorry, I lost you. For adaptation to undergrads?
Yeah, to undergraduates. Yeah.
Yeah, I think that it might be start with smaller projects, like either, for example, undergraduates that do some lab work. They are involved in some lab experiments, or they do some summer projects that they do research for a couple of months. They can start like with simple questions, simple steps, start documenting, like, or familiarize themselves of what is reproducibility of the work. And as the questions are becoming more complex, more levels can be added.
Yeah, I love that idea, actually. I'm not sure if the DSI has a summer program, the SUDS, Summer Undergraduate Data Science program or something, but yeah, maybe this would be perfect to have to implement. Are there any other questions or comments? No? Right. Well, I might just say thanks. Oh, sorry. Great talk. Sorry if I missed it. Is there a link, Paraskevi?
So I don't have a link, but I have all material. Hi, Luke. we know each other. So yes, I can have all material and definitely share with you. There is also, this work has been uploaded to the Design Thinking for Scientists course. It's actually on the UFT website. So a basic summary, it can be found there. But I can ask my supervisor and upload everything in the repository, GitHub repository we have from the lab. And if I get permission, I can upload everything there. It is open.
Oh, thank you very much.
No problem.